Most welcome to Dr. Acharya Academy. Today, I'll discuss the ideal gas equation. In previous 3 to 4 class, I explained the different laws, Boyle's law, Charles' laws, Avogadro laws, and now we'll combine in one equation, which is called the ideal gas equation. And this topic has been taken from the unit number 5, CBSE Chemistry, class 11 syllabus. Today's class number is 102. In the previous class, whatever I discussed is the Boyle's law, Charles' law, and Avogadro's law. And Boyle's law at constant temperature and the number of moles in the volume is proportional to the 1 by P, that is pressure. At constant pressure and number of moles of gas in the volume is proportional to the absolute temperature. It is called Charles' law. You understand from the previous class. And similarly, at constant pressure and temperature, volume is proportional to the number of moles, which is the Avogadro's law. So if you combine all three, the mathematical calculation, it will come V is proportional to N and T is on, and by here also by P. So V is proportional to NT by P. You can rearrange this equation that V by N is RT by P. R is on constant. We introduce because in the left side is the proportionality. So V by N is equal to capital letter R T by P. This capital letter R is the proportionality constant. And if we rearrange this equation, then we will get PV is equal to nRT, and this equation is called the ideal gas equation, which is the combines of the different gas laws, that is Boyle's law, Charles' law, Avogadro's laws. And here we can calculate the value of the R, that is proportionality constant. R is equal to PV by Tn. This simple mathematical expression. So R is called the gas constant, and this value of R is same for all gas. That's why it is called the universal gas constant. So this capital letter R is same for all gas, and it is called the universal gas constant. So this equation shows the value of the R depends on the unit, the P, V, T at the definite amount of the gas, where the N also will remain same. If you consider the same amount of gas, and these three variables P, V, and T in this equation, we know this, and then fourth one we can calculate. That means R we can calculate with this equation. So you can rearrange once again. V by NT is equal to R by P. This is the rearrangement of this above equation. And N, R, T and P are constant. If we consider the constant temperature and pressure and N moles of any gas, then the volume will have the same volume. So volume will be same if 1, 2, 3, 4 all are constant. Again, this equation PV is equal to nRT it is applicable to any gas under those conditions when the behavior of the gas approach the ideal behavior. That's why it is called PV is equal to nRT. This equation is the ideal gas equation. The gas which behaves ideal nature. Ideal means previously I already discussed that no interaction between the gas molecules in the gas. That is called the ideal gas, and in this ideal gas condition, this equation PV is equal to nRT will be applicable. So the volume of 1 mole of ideal gas at STP conditions from the equation, this equation, this to this one you have to calculate. So you know P is 1 bar and T is the 273.15 Kelvin and N is the per mole. So N is equal to 1 because unit per mole. So volume under this STP condition, standard temperature and pressure condition, is the 22.710981 liter per mole. The value of R for 1 mole of ideal gas can be calculated under this condition. If you put this value under STP, standard temperature and pressure, all value put, then after the calculation, the value of the R is 8.314 joule per Kelvin per mole. So you can write that at STP, the value of R is more refined in nature. It is the 8.20578 multiplied by 10 to minus 2 when your unit change. Now it is the liter atmosphere per Kelvin per mole. Previously in this calculation we expressed the value of the R in joule per Kelvin per mole, and when we calculate this value down, then the unit is liter atmosphere per Kelvin per mole. So this ideal gas equation is also called the equation of state. And now we'll consider that if the temperature, volume and pressure of a fixed amount of gas is varied from T1, V1, P1 to T2, V2, P2, then this is the main equation. When this first condition is there, this for temperature, volume and pressure, and it is the equation for the second condition when T2, V2 and P2, and if we combine these both, that means NR in both cases is the same. So this one is equal to this one, that means P1 V1 by T1 is equal to P2 V2 by T2. So this equation is very useful equation. You can see that here variable is 1, 2, 3, 4, 5, 6. And out of 6, if you know the value of the 5 variables, then automatically unknown that 6th one you can calculate very easily. And this equation is called the combined gas law. So you can see the problem, mathematical problem to calculate. Here the temperature is there. Always temperature you have to convert from centigrade to the Kelvin by adding 273.15 with the value at centigrade. You have to remember always. And the pressure is the millimeter of Hg pressure. A gas occupies 600 ml volume, and what will be pressure at a height where the temperature at 10 degree and volume of the gas is 640 milliliter. And then we'll follow the same equation what was just now we discussed. P1 V1 by T1 is equal to P2 V2 by T2 here, and then First, you have to convert the all value in the desired unit, and you are converting that pressure as it is P1 760 millimeter mercury, V1 is the 600 ml, we put from there, and T1 also, whatever I told, approximate 273, you have to add with the centigrade to convert in Kelvin. And for the V2 is already mentioned 640 ml, and T2 again the 10 degree centigrade, 10 plus 273 means 283 kelvins. So what is unknown there? Unknown is the P2. So P2 is equal to P1 V1 T2 by T1 V2. This is simple mathematical calculation, and you have to put that whatever right side all value you put, and after that you will get the P2 is 676.6 millimeter of mercury, and this is your answer to this mathematical problem by using this simple equation. P1 V1 by T1 is equal to P2 V2 by T2. We have to remember this. So now we'll see the relation between the density and molar mass of the gaseous state. So the ideal gas equation, we know that N by V, by rearranging this, N by V is equal to P by RT, and then replacing N, this N replaced by the M by M. Small letter m is the mass, and M, capital letter M is the molar mass. So if we divide, then we will get the number of moles denoted by small letter n, and if we put this value, then we can rearrange in this way. Small letter m by capital letter MV is equal to P by RT, and then this m, small letter m by V, that is mass per volume, this is considered as the D, density. So D by M is equal to P by RT, but the D is the density. So if we rearrange, then M will be dRT by P. In this way, we can calculate the density and also the molar mass from this equation. So I hope that you understand this class, that what is the gas equation and what is the universal gas constant, what is the value of R, and finally how to get the equation in respect of density. And one problem is there where the pressure you can get from the different types of variables, and how to calculate by the equation whatever I mentioned here for the molar mass. Thank you so much.